You know what? I'm feeling confident that despite the fact that you've never quite understood electricity, I can make you understand it in just this one video. Watch this. Your understanding of electricity comes from understanding those fundamental things: current, potential difference, and resistance. We're going to start with current. Say it with me just like I make my classes. Current is the rate of flow of charge. The rate of flow of charge. So think of it as the flow, just like current in water. If you have a series circuit, there's only one way that it can flow. So the current, the flow, anywhere in this series circuit will always be the same. So current is the same everywhere in series. If, however, we add another loop to make a parallel circuit, then the current has more than one option of where to go. It could go this way, or it could go this way. So in a parallel circuit, the current will split at a junction. This point here is a junction. Current splits at a junction. It's shared between these different branches of our circuit. And by the way, for that top level knowledge, it will be shared in proportion to the resistance. So if there's more resistance, there'd be less current on the branch because resistance opposes current. However, let's keep it simple. Say you had two identical components on your circuit here. They'd have the same exact resistance, so the current would be split perfectly evenly. If, say, we had 4 amps here, then that would split into 2 amps and 2 amps, and then it would join up again to give us 4 amps here. Remembering that current always flows from the positive side to the negative side. Positive being the long line, negative being the short line on your battery or cell. So current in series, same everywhere. Current in parallel splits between those different branches. Next, potential difference. Think of the potential difference as the energy per unit charge. The energy that each of those electrons has to distribute around the circuit. So the electron from your power supply picks up its energy and then distributes it to the different components in your circuit as it goes around. For that higher level knowledge, that potential difference will be shared in proportion to resistance again. But this time, the more resistance the component has, the more share it gets of that potential difference. Think of it like it needs more energy to get through that component. So here we have 2 identical components, 2 bulbs. Say we had 12 volts here, these would each get 6 volts. If I had 2 different components and this one got 3 volts of the 12 volts, how many would that get? The rest, it would get the 9 volts. But notice we get that same total here as what we had at the power supply. So it's shared between components in proportion to their resistance. What if we have a parallel circuit and adding an extra loop? Again, fundamentally, remember, potential difference is the energy that the charges have. These ones that go this way will only pass through these 2 components. So of the 12 volts they have, they'll share it as they did before between these components. However, the other electrons that go to the second branch will only pass through that single component in my example here. So all 12 volts of energy they pick up are going to go straight to that bulb. So in parallel circuits, you get the same total potential difference on each branch. Just remember though, it will be shared between the components on each branch as it is always. Like so. Great, lastly we have resistance. That's just a measure of how much a component opposes the flow of charge, opposes the current. You need to know how you get the total resistance in series and in parallel. Here's a circuit with 2 resistors, both of them are 10 ohms.